in fascinating times. Technology advances rapidly and all kinds of new products arrive on the market. One of today's challenges is to integrate electronics and sensor circuits seamlessly in unusual shapes into protective clothing, a wide range of devices, and even ones that can be implanted. But as intriguing as this may be, there are still many challenges to be tackled. One of the challenges is that nowadays, most components of our technologies are integrated on flat printed circuit boards. These boards can be fabricated at high throughput, but cannot be integrated seamlessly at all. This is where the TERASEL project comes in. The idea behind TERASEL is to combine today's standard technologies for PCB fabrication and polymer processing in exciting new ways. Merging both worlds can result in randomly shaped electronic circuit boards. This can be achieved with current, existing processes and machinery, which makes it highly cost-effective, space-saving and very versatile. Major European companies and institutes are teaming up with TERASEL to establish and demonstrate a complete industrial production chain for the fabrication of these randomly shaped electronics and sensor circuits.
TERASEL uses technologies from mainly two industrial sectors. On one hand, from the electronics sector, where we produce printed circuit boards and assemble electronic components on those printed circuit boards. The second sector is the one of polymer processing, where we use technologies like thermoforming, injection molding. And by combining these basic technologies in an intelligent way, we are able to create smart plastic objects.
The electronic circuits are first fabricated on flat and then transformed into a 3D shape.
At this moment in electronics industry you have a lot of separate components which you have to put together to get your final product. And with TERASEL we have the possibility to put all components together in one part.
Industrialization is a very important part of the TERASEL project.
You normally start a project as a development project, so you look what you can realize, for example, in an institute, at a university, or in a smaller group, or in a lab. In fact, you have some prototypes, they look very nice. But at the end, you want to realize them, you want to produce them, and you want to sell them. And that means you have to transfer each step you're doing in the lab into some industrial environment. If you don't have the equipment, or the process step that you have in mind in lab doesn't fit to the industrial environment, the product will never be realized.
The TERASEL consortium is already developing several applications which demonstrate the wide range of possibilities. Today, LED technology is often used as a light source, but is difficult to use on arbitrary designs. The LED also generates a light beam at a low angle and needs additional optics for light spreading. A stretchable circuit design with integrated LEDs diffuses the light more omnidirectionally. 3D-formed lighting may therefore open up new perspectives for future lighting armatures. The control panel on washing machines often uses a mechanical part for program selection. Imagine a control panel with a 3D-formed design, with seamlessly integrated interaction areas. In this demonstrator, the traditional complex mechanical setup is replaced by a lightweight solution and very thin design. With the TERASEL technology, it's much easier to integrate sensors and touch control in devices. Excluding the mechanical part of the buttons makes devices more sustainable and reliable. The third demonstrator is focusing on these 3D-formed buttons and user interfaces, where integrated sensors replace all mechanical parts. Your car probably has a mechanical glove box handle. TERASEL's fourth demonstrator opens the door to smart surface interiors in cars. All electronics and wiring can be seamlessly integrated in the curved design of the glove box door. Until now, the LED ambilight panels in the back of a TV had to be connected in the corners with separate connectors. The fifth TERASEL demonstrator shows that it is possible to design ambilighting in one piece and with arbitrary new designs. These are only a few examples which demonstrate the possibilities. The TERASEL project will eventually generate a new step in an era of 3D shaped circuit boards and will open roads to new product concepts and markets. A wide range of industrial sectors will definitely benefit from the novel TERASEL capabilities.